I have added a single image of some practice problems in the Show Me folder. Feel free to add that to your notes. It will give us a preview of what tonight's homework is like so we can try it together. Where we left off in class, we were talking about the solubility rules and how to know how to write the equations. Remember, soluble salts are strong electrolytes, so they will be written as aqueous and broken apart. Insoluble salts will be written as solids. So the first problem here says when the following solutions are mixed together, what precipitate, if any, will form? So we can see that the two things that are mixed together are written here. It's our job to figure out what the products are and if either of them will be a solid based on the rules. This is a double replacement reaction, which means I'll put the cation of one with the anion of the other, and the cation of the second one with the anion of the first one. I do have to know the charges, however. When mercury and sulfate come together, I have to know the charges to know if I should write a subscript. Check the back of the periodic chart. Sulfate has a 2 minus charge. Mercury's plus 1, and that one I actually know by looking at nitrate. Nitrate's minus 1, and there's 2 of them. So to balance a 2 minus, I need a plus 2, and since there's a 2 right here, each one must be plus 1. So to put these two together, this has to be Hg2SO4, and the other substance will be copper. I know copper has a 2 plus charge, right? Again, this is 2 minus, so this has to be 2 plus. And nitrate. Nitrate's always minus 1. So I'll need 2 of these. Again, how do I know the charges? There's 2 ways to know the charges. For the polyatomics, I can check the back of the periodic chart. Sulfate is minus 2, nitrate is minus 1. For the cations, I may have to do a little mathematical figuring. If this is minus 2, this has to be plus 2 because they're in a 1-to-1 ratio. This 4 is a part of the SO4 symbol. There's actually just one sulfate. If this is minus 1 and there are 2 of them, then everything that is associated with mercury would have to equal plus 2 to balance out the minus 2. And since there are 2 of them, I divide that by 2 to get plus 1. Now I'll use the rules to determine if either one of these substances will form a solid or neither. Rule number 1 says most nitrate salts are soluble. So this has nitrate in it, which means it should be aqueous. Now, these rules are, the ones at the top are the best predictors, meaning if you find a conflict between rule number 1 and one of the later rules, you'll go with rule number 1. Rule number 1 trumps rule number 2, trumps rule number 3, and so forth. So since it has nitrate, I don't have to check any other rule. That is enough because it's rule number 1 and it's very important. All right, what about the next one? Salts containing plus 1 ions, that's none of these. Salts with minus 1 ions, or when they're combined with mercury, well, that's not this case. We don't have a minus 1 ion combined with mercury. Salts with sulfate, that's us, are soluble except for the following. Aha. So soluble except, which means this one is not soluble. It does not dissolve in water. When you mix it in solution, it will form a solid precipitate. So we put an S. That one's done. Next, we'll write the products. Remember, it's a double replacement reaction, so the nickel will combine with the chloride, but I must check the charges. So the charge on nitrate is always minus 1. See here, there are 2 of them, so that's minus 2, so the nickel must be plus 2. Chloride's always minus 1. It's not a polyatomic. So to write nickel chloride, it would have to be NiCl2. And to write calcium nitrate, nitrate is always minus 1. And calcium is always plus 2, right? I can just check the periodic chart. It's on the front. So this is not one I had to work to figure out. And in order to put these together, I would need 2 nitrates. Remember, I use the parentheses so that no one thinks I'm writing the number 32 right here. I'm writing NO3 2 times. All right, which one of these, if either, will form a solid? Rule number 1, nitrate salts are soluble. Right away, I'm done. Rule number 2, or at least I have identified one that will not form a solid. Rule number 2 talks about +1 ions. That does not apply. Rule number 3 talks about -1 ions. Aha! Chloride is a -1 ion. Are soluble except when combined with these. Well, nickel is not one of those. So I don't have to go any further. This should also be soluble because it has chloride ions and it's not one of the exceptions. So I'll put aqueous here. When we have this scenario, it's called a no reaction. So we're kind of done with that one. Sometimes we'll just write no reaction for that. For the next one, it says from the previous problem, write the balanced formula, the complete ionic, and the net ionic equation, or no reaction. So let's do it. The balanced formula for part A is, we'll just copy and paste this because we already have it written, hopefully. So that is the formula equation. Let's make sure it's balanced. I don't think I balanced it. Mercury, sulfate, nitrate, copper. Okay, looks balanced. I like to write the ones. Of course, ones are not necessary. This is the formula equation. Now I need to write the complete ionic equation. In the complete ionic equation, I will show the ions separating if they are aqueous. If the solute is a solid, I will not separate the ions. So here I will not be separating the Hg2SO4, but everything else will separate. Mercury is the first thing I'll write. I have to write it with its charge. We already determined it had a +1 charge. I also have to balance the equation. When Hg2NO32 comes apart, there will be 2 mercuries. It's not going to be a Hg2 molecule, so I won't write it as a subscript. There will be 2 of them, so I write it as a coefficient. And it's aqueous because it's in solution. Nitrate has a -1 charge. There will be 2 of those as well because of the subscript 2, and it should be aqueous as well. Copper has a 2+ charge, aqueous, and there's only 1. Sulfate has a 2- charge, aqueous, and there's only 1. Hg2SO4, the solid, will not come apart, so I write it intact. Copper has a 2+ charge, it's aqueous, there's only 1. And nitrate has a -1 charge, there will be 2 of them, and it is aqueous. So that should be balanced. Feel free to double check it. Finally, the net ionic equation is the one in which we write the equation with no spectators. So I'm just going to copy and paste this one, and I will identify and remove all of the spectators. Spectators are ions that are present on the left side. Oh, I'm sorry. And present on the right side. For example, this nitrate is on both sides. This copper is on both sides. What you will find is that the ions that remain are just the 2 that are involved in making the actual solid. So we can go ahead and delete this, and we can go ahead and delete these because they are spectators, and this as well, also a spectator. And then I can just kind of squeeze the rest of these together. What I should have is the net, right, after all of the additions and subtractions, and it should also be balanced. 2 mercuries, 1 SO4, 1 SO4. It's balanced. The ions have charges. There is no charge on the compound. Of course, it's neutral. These are aqueous in solution, and then they form a solid. That is the net. Now, the same thing is true for the second reaction, except when I get to the stage where they're all separated, they will all be spectators. So for the net, there is no reaction. You cannot write it because there's no solid to be formed. They would all be spectators.